In this video, we'll discuss how to find the area shared by two polar curves. In the last video, we talked about the area between two polar curves, and that was a little different than what we'll do in this video. In this video, we'll have two polar curves overlapping, and we'll look for the area that is shared by them. So we want to set up the integral that will find the area shared by the cardioids r equals 2 times the quantity 1 plus cosine theta, and r equals 2 times the quantity 1 minus cosine theta. So always the first thing I want to do is graph my equations. So when I graph them, I see that they're basically mirror images of each other over the y-axis, and they're sideways cardioids. So they have these little raindrop shaped regions that they share over the y-axis. So we know that the right cardioid, if you graphed this in your calculator or on the computer, then you know that the right cardioid is r equals 2 times the quantity 1 plus cosine theta. And I'm going to call that r sub 1, just to keep track of which equation is which. The left equation is r sub 2, and that is the 2 times the quantity 1 minus cosine theta. And what I'm looking for is I'm looking for the area shared by them, so the region that I've shaded in now with those teardrop regions between the two cardioids, and we want to think of this as two areas added together. They may have different bounds because of how the curves are traced out, so we need to be careful of that. In this particular case, we could use symmetry, but I'm going to go ahead and find the bounds for each part of the region so that you'll know how to approach it in case you do not have symmetry in one of your problems. So I'm going to figure out how the r sub 1 curve is traced out. So remember, r sub 1 is 2 times the quantity 1 plus cosine theta. When theta equals 0, r sub 1 equals 4. So I'm on the positive x-axis at theta equals 0. And if you graphed this in your calculator and paid attention to how it was traced out, you would see that it went in the counterclockwise direction. So I'm going to just put my little arrows showing me that it's going in the counterclockwise direction. So I know that my first boundary that I hit of that teardrop region is going to be theta equals pi over 2 and r sub 1 equals 2. So you find the r value by plugging pi over 2 into the r sub 1 equation. And then at the origin, that's when theta equals pi and r sub 1 is equal to 0. And then at the bottom of the shared region, theta equals 3 pi over 2 and r sub 1 equals 2. So we've got our bounds for the left portion of the shaded area or of the shared area. So if I go from pi over 2 to 3 pi over 2, those will be my bounds for r sub 1. So the area of the left shaded region is the integral from pi over 2 to 3 pi over 2 of 1/2 times r squared, where r is 2 times the quantity 1 plus cosine theta. So I have 1/2 times 4 times parentheses 1 plus cosine cosine theta quantity squared, and I should have a d theta in there. And now I want to find the area of the right part of the shared region. So I know on my curve r sub 2 equals 2 times the quantity 1 minus cosine theta, that when theta equals 0, if I plugged in a 0, I would get 2 times 1 minus cosine of 0. 1 minus 1 is 0. So I'm at the origin. So when theta equals 0, r sub 2 equals 0. And this curve is also traced out in the counterclockwise direction. So the first place I'm going to end up at the top of the shared region, I have theta equals pi over 2 and r sub 2 equals 2. So that's actually a shared bound with the other one, but that's actually the upper bound for R2, whereas for R1 it was the lower bound. So let's think about where this bottom part is, the bottom bound of the shared region. That's going to be at theta equals negative pi over 2. And if I plug in a negative pi over 2 into my r sub 2 equation, then I get r sub 2 equals 2. And so if I use the bounds negative pi over 2 to positive pi over 2, then I'll get the right half of the shared area. So the area of the right shaded region is 1/2 integral from negative pi over 2 to pi over 2 of 4 times the quantity 1 minus cosine theta quantity squared d theta. So what I want to do is take the two integrals that I've set up, and I would add those together to get the complete shaded area, or the complete shared area between the two cardioids.